helicopter view of his life, so insignificant, next to this vast open desert. What is in his mind? Will we ever know? But we feel for him, because we are right down with him, experiencing his plight, blah, blah, blah. Anyway, yeah, he's very static right now, because he's just like standing there, and this world is just like bidding him to keep walking, but he's not. So let's fix that. So, all right. So we are over here. We're using myDudeFace variable to draw Hrozgo on the screen. And over here, we're just kind of like defining it at the beginning of everything as 1. But really, we want to be able to plug in these like this kind of flipbook animation and have, you know, a pattern of picking these in order so that we can animate some stuff and create some like visual interest of the animation variety. How do we make that happen, right? So like, okay, yeah, we need to change myDudeFace on every frame. myDudeFace is, let's make a function. Let's call it flipbook. And we're going to pass to this function that doesn't exist yet a table. That's what we want to do, because we want this function to take care the flipping through a table. So here I'm going to say Hrozgo. And so flipbook doesn't exist. So let's try some flipbooks. So over here, I'm going to say function. I just went to another tab. This tab is going to like get loaded before this tab. Doesn't matter. I'll just do it on in here. So flipbook, T for table. Let's do that. And so flipbook, we pass it a table, and it returns some value from that table. Okay. What is the easiest way for us to return some value from this table? Well, let's go back to our friend, the random function, which lives in the math section. Where's that? Math. Random x. And look it up over here. Rand. Where's it? There we go, rand. Returns a random number n, where if you want an integer, use floor. If x is an array style table, which our like list of sprites is, return a random element between table 1, which is the first part of the table, and hashtag table. This is cool. Hashtag table, we haven't talked about hashtag table, but this is a property of tables. Let's look up tables. Tables. Give me the section heading tables. Tables. There's a bunch of like refreshers on how to do stuff here if you ever forget what's going on with tables and which brackets are which and when to use them. Just load up the documentation. But yeah, over here they also mentioned the hashtag operator, which allows you to sort of like figure out how many things are in a table. But yeah, let's start by just using a random, and we're gonna return a random value from t. So by passing this table that we are throwing into the flipbook straight into this random function, and then whatever this expression returns, we're going to return out of our function into myDudeFace, right? So we're just like plopping Hrozgo into flipbook, and it's returning a random frame for us. So here's Hrozgo. Look at him sort of run. If animation were just like randomly pulling frames from a set of available animations, this would be effective. Maybe this would work better on SNED. Let's try SNED. Oh, he's like really I don't know, what is this? It's jittery. It's not working on SNED either. All right. You know, this is clearly a wrong flipbook. animation. So what other options do we have as far as creating like a counter of sorts to cycle through our sprites? Well, we could just create a counter. So I'm just going to call it the Tim. It's going to be our counter, and Tim is going to be 0 at the beginning of the world, and then every update cycle, Tim is going to grow by 1. And so let's see if we can go into our flipbook animation. So this is our. So I renamed this old one wrong flipbook, and this one's going to be flipbook. So this is going to be our flipbook. So now we have Tim to count on, and we have this array T. So we're going to do it like this. I'm going to grab our array T, and I'm going to use the square brackets. Remember, square brackets will help us reach into the array T with some kind of key value, 1 or 2 or 3, the address of these individual frames that we want back from inside of the table. So here I'm going to put Tim. So whatever the value of Tim is going to be, that is the frame that our flipbook animation is going to return. So if we run this, did it work for at least a little bit? Let's look at that again. Whoop, 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 whoop. Yeah, that totally was the right animation. It is just that we're running out of frames. Runtime error, line 25, tab 1, sprite mydude, but attempt to perform arithmetic on a global mydude face, right? So it's going to throw us in this line right here, because mydude face is null, because our flipbook animation has returned null at some point. So let's try printing it on the screen so that we know what it is. So I'm going to print it at let's see, yeah, I'm going to print Tim, and I'm going to let's do it at 10 10 and do it in red. Now I'm just typing print here right in the middle of our flipbook animation, because I'm using the flipbook animation inside of the draw call after I have cleared the screen. So this thing is going to clear the screen, it's going to run the flipbook animation, it's going to print this one thing. If I happen to have put this thing inside of the update call, right under Tim, which is totally doable, it's just that my dude face will be figured out and then passed to this draw function that's going to decide the drawing. But I wouldn't be able to like preview what the function is doing by printing it on the screen, because like this would be calculated before this screen is cleared, so I would never actually see that thing on the screen. So I'm going to undo this and put it back over here in the draw call. But this is a choice. I made this choice. It's just so that I could like test it easier. But maybe you wanna calculate this over here and have a different way of printing Tim. All right, so it goes to 7, right? And so Tim is 7. So what does the T of Tim look like at that point? So this would return the actual value that we are returning out of the flipbook animation. So as opposed to the index itself, right? Nil, just as I expected. So we're running out of the table. This Tim is increasing forever and never returning back. So, one way of dealing with this is to say, if Tim is bigger than number of craws go, hashtag craws go, then Tim is 0 and whoops. Is it bigger than equal to? Nope. And Tim is, oh no, the Tim is 1. I think that one is crashing. So, this works. This works for Crossgo, but as soon as we put in sned into the as our dude, it's gonna crap out because sned doesn't have the same number of frames. I guess we can go back here and write sned, and now it's going through the snaky stuff. So in addition to the fact that this is just way too fast, this counter business is we need to kind of slow it down. Like on the plus side, it works. On the minus side is like we have to kind of like babysit each and every application of our sprites, and we have to make a different counter for every character, and it's just untenable. It's not something that you want to keep doing if you have 20 like characters on the screen at one time, right? Like it can't be done. So let's get a bit smarter about this, and the way we're going to do that is through our friend the modulus. So if you remember, over here we use the modulus to figure out the remainder when figuring out the pixel coordinates of different indexes on the map. But we can also use it to divide our timer by the number of frames that we have in our flipbook. So let's make this a little bit easier to debug. So I'm going to say local index is whatever this value is, and then I'm going to print it here, and I'm going to return it. I'm going to return the t of index. So I'm going to return whatever the index, the sprite value is based on the index that we're going to calculate in this line. Whoops, no, this is wrong. Okay, so far, this is our first stab at it. So this is the still wrong flipbook. Let's keep documentation of our mistakes. This is going to be our better flipbook. Index Tim, right? Modulus #T. So here we solved like a whole bunch of our problems because we are going to like collect the index by using the modulus of the length of our business, and any table that we throw in here, it should work. So let's run this. Whoops. Runtime error line, blah, 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 0. Okay, so over here with this red 0 tells us that we goofed. Goofed where? Oh, because okay, so modulus gives us the, a number from 0 to however many items there are in the table, but our table's indexes, they don't start with 0, they start with 1 and go 2, 3, 4, 5, 6, and there's 6 items in here. So actually, we don't, because modulus 6 is going to give us 0, 1, 2, 3, 4, 5. So we just need to add 1 to whatever this index is. So I'm just going to add 1. So this one should work. And it does. And we just have one counter that keeps increasing forever, and we are whoa, it's too fast. But we can give it a different dude, and he runs too. And can we do wolf? Well, we do have a wolf, but it's running really fast. If we make this one too wide, will our math catch up? It will. All right. So a lot of the parts of what we've done work. It's just that it's too fast. So how do we slow it down? What do we do with our equation to slow it down? Well, we need to introduce a kind of a frame rate into our system. So frame rate, I'm going to say, I don't know, some number 5. And over here, we're going to divide by frame rate. And no, wait. We're going to divide Tim by the frame rate before we do other stuff to Tim. And we're going to Flora. Doop, 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 doop. That's good. Frame rate of 5, frame rate of 8. Slower. Frame rate of 2. Frame rate of 4. I mean, technically this is not a frame rate. This is like how many frames each animation frame is going to take. So it's like the frames per frame. And it's now like every 4 frames, it's going to be the same frame. So if we stop it and then, oh wait, period? Yeah. 1, 2, 3. 1, 2, 3, 4. So yeah, so by pressing period and then hitting enter, you can advance your interrupted game by 1 frame, and that will help you like debug some stuff. So if you can notice every time I hit enter, the waves in the background, like the hills, move by a pixel, but the wolf, it takes him, whoops, it takes him 4 frames of the background to advance 1 frame. All right, so that's what R4 here means. So this is like, I'm gonna dub this flipbook good enough. But I'm gonna give you one more flipbook that is a little bit more graceful than this one because it doesn't require us to use doesn't require us to create a whole new counter to keep track of stuff. So Tim can go away. I'm just gonna comment out Tim. Don't need you, Tim. You don't need to grow, Tim. Stay the same, Tim. And here it's gonna be our definitive flipbook animation situation. Instead of using Tim, I'm going to use time. You can actually just say time, or if you're feeling really concise, you can just say T. And that's the same thing. So I'm just gonna level it up a little bit, make it shorter. So we're gonna actually use the time in seconds that like instead of a timer, and this is going to change our math a little bit, but not that much. So let's run this. Oh, runtime error, local frame rate, attempt to call local t, a table value. Oh, baloney. Okay. All right. So I tried to be too clever. Like notice that inside of our flipbook animation, we are calling t, like we're calling our inputted table in there t for the purpose of this function. And that is interfering with this one because we are just renaming an alias that Pico-8 already provided for us. So one way to get around it is to rename this to something else, and we're going to call it our animations. So I'm just going to rename all of those, like these two basically, to be and then this one too. And this should work. Oh, baloney. Okay, so it's going 4 seconds per frame. All right. So we need to adjust our frame rate, and let's make it so that we'll use a different variable here. So I'm going to call it fr because I'm so concise. So fr is going to be 0.5. Oops. 30. Wait, what am I doing here? Okay, I'm dividing it. Let's multiply. Let's multiply by 0.5. So there we go. So it's half a second per frame. We want a little more than that. Faster, faster. Oh, come on, guy. None of those things did anything because I'm renaming things and not consistently. All right, so the fr here and the fr here are the frame rate. Okay, and then this is too slow. Okay. Half. Just make twice 2 seconds. 1, 2, 1, 2, 3, 4. All right. That works. Let's change our guy to crossgo and width of 1. Doop, doop, doop. Frosgo the man is on a journey. Well, he's not a man. What is he? What even is Frosgo? He is a devil. Where's he going? What is he looking for? Will we ever find out? Hope so. Boy, howdy. Okay. So we talked a little bit about the advanced sort of like super sprite function that you can grab an arbitrary location in the sprite sheet, not just based on the sprite tiles, but we used sprite tiles and some fancy math to reach into the sprite sheet and extract like pixel coordinates from actual like sprite indexes, and we have created a series of wrong and like good enough flipbook functions. If you ever need a flipbook function, just grab this, comment out this print line here. Let me save this, haven't saved it in forever. And this will, this is, you know, good enough for your game. If you want to change the frame rate for your game, maybe it's too fast, too slow, whatever, you just adjust this number. Yeah, just plop this into your stuff. It'll work. For any of your like flipbook animation needs, you can also like you know we're using this for animation purposes, and we're animating the numbers that are returned from this. But there's no reason that you can't like flipbook through any other like collection for any other reason as well. I'm gonna take a break, and then we're gonna level up this table game of ours in newer, better, greater ways.